Hi guys, we are going to start chapter 9, lesson 4 in your science books, and we're going to read about magnetism. This one's going to be kind of fun. So let's start on page 411. Magnetism. Does the door of your refrigerator look like a scrapbook and message center? Papers, photos, notes, and reminders may be held in place by many colorful refrigerator magnets. Magnets attract the magnetic materials such as steel found in many refrigerators and paper clips. This attraction is what makes the magnets cling to the refrigerator and to the paper clips. As you may know, all magnets have the property of magnetism. Magnetism is a force that acts on moving electric charges and magnetic materials. So how do magnets support a heavy maglev train? Electric current produces enough magnetic force to lift the entire train. The pushing and pulling force between the magnets also moves the train along the track. Magnetic fields. Each magnet has a magnetic field around it. A magnetic field is the space around a magnet in which magnetic forces operate. A magnetic field extends out in all directions from a magnet. The exact shape of the magnet depends on the exact shape of the field depends on the shape of the magnet. Magnetic poles. The two ends of a magnet are called its magnetic poles. The end of a magnet labeled north is pulled to the geographic north by Earth's magnetic field. The end labeled south is pulled to the geographic south by Earth's magnetic field. The magnetic field is strongest at the magnet's poles and gets weaker away from the poles. The north pole of a magnet attracts the south pole of another magnet. The north pole repels the north pole of another magnet. Similarly, the south pole of a magnet attracts the north pole of another magnet, and the south pole repels another south pole. So here's how I want you to remember that. If you have two magnets, and one side is the north and one side is the south, if you put the north against the south side of another magnet, they're going to zap together. We've done this before. We've put magnets on our refrigerators, or we've played with magnets. But if you take a magnet and you put the south pole against the south pole, or the north pole against the north pole, they're going to push away from each other. So they're going to repel. Okay? We're going to need to know that for one of the questions in a minute. Let's read about magnetic compasses. A compass is a helpful, easy-to-carry tool. Weber and Farah, no. A compass is a helpful, easy-to-carry tool. Wherever you are on Earth, one end of a compass needle will point approximately to Earth's geographic north pole. It follows an imaginary line that connects the magnetic poles of Earth. Once you know which direction is north, you can easily determine south, west, and east. For a compass to work properly, its needle must be lightweight and must turn easily. The compass cannot be close to a magnet, otherwise the needle will respond to the pull of the magnet rather than to Earth's magnetic field. So here is what I want you to take away from this lesson. So here's what I want you to remember. Magnetism is a force that acts on moving electric charges and magnetic material. Electric current produces enough magnetic force to lift an entire train. Do you remember what electric current is? We learned it last lesson. Electric current is an electric charge in motion. I want you to remember magnetic field, which is the space around a magnet in which magnetic forces operate. Magnetic fields extend in all directions from the magnet. Magnetic poles. Magnetic poles are the two ends of the magnet, north and south. The Earth has magnetic poles as well. I know you've heard of the North Pole, but have you heard of the South Pole? Earth has both. Earth has a north and a south. Magnetic fields are strongest at the magnet's poles and get weaker as you move further away. Look at the pictures on page 412. There are 3 of them, and they're going to help you understand magnetic poles. It is important to remember that the north pole of a magnet attracts the south pole of another magnet, but the north pole repels the north pole of another magnet. Remember, they're going to push each other away. And last, magnetic compasses. Wherever you are on Earth, one end of the compass will point approximately north. A compass cannot be close to a magnet because this will cause the compass to respond to the nearby magnet instead of Earth's geographic north pole. All right, take a brain break and I'll see you in a minute.